All right, guys, operations on rational expressions. We're starting simple today, okay? A rational number in general is just any number that can be written as a fraction. What do I know, though, with fractions can never happen? What can the denominator never be? Zero. So we have to figure out anything that would make it zero and say, can't have that. Okay? All right. A rational expression, it looks like a fraction, but the numerator and the denominator are both polynomials. Okay? Once again, the denominator is not equal to 0. Okay? Not equal to 0. All right. Examples and non-examples. Okay? Examples and non-examples. All right? A simple rational expression might look like this. 1 over x. This is actually the parent function. It's the most basic rational function we have. Okay? We might have something that looks like this. X plus 2 over x minus 3. One very common mistake right here is that people see these x's and they just want to like cancel them out, and we're left with the fraction negative 2/3. But we can't do that here because there is an understood but unwritten set of parentheses blocking off the numerator and denominator. That's because this is x plus 2 or x minus 3. If addition or subtraction is happening, okay, then we can't cancel those out. Only if they are being multiplied, okay? We might have something that looks like this. A polynomial that has been maybe multiplied out and not simplified at the moment. Okay? All right. Basically, anything that has a polynomial over another polynomial. Anything like that is totally fine and is considered a rational expression. Okay? Now, non-examples. What is a rational expression not? It is not the square root of x plus 2. Now, I could write that as a fraction. I could put this over 1, okay? But the problem is the radical. We cannot have radicals here. Okay, along those lines, if I have something like x plus 1 over the square root of x minus 3, that's a problem. Hey.
The square root of 4 over like x plus 1,
that would be fine.
Okay.
Yeah, because the square root of 4 simplifies. Okay? Another thing that we cannot have right here is 2 to the x power. All right, so what makes these things not rational expressions? Okay, we cannot have radicals or variable exponents. Okay? We cannot have radicals or variable exponents. Okay. To work with radicals, or I'm sorry, rational expressions, okay? Being able to factor is our lifeline right here. This is critical. We have to be able to factor something completely, okay? This is so important, okay? So I gave you this flow chart again just as a reference tool. We know that we always want to look for a GCF, and whether I have 2, 3, or 4 terms really kind of depends on how I'm going to factor that expression, okay? So this is just a reference for you as we move along, okay? All right, so just some information about simplifying rational expressions, okay? A rational expression is simplified when the numerator and denominator have no common factors other than the number 1. So they have nothing else alike. Just like simplifying fractions, we are going to divide out all common factors. We want to get rid of anything that they have in common. Okay? The blank of an algebraic expression is the set of real numbers that the variable is permitted to have. So in other words, my variable is typically x, right? So what is x allowed to be? What represents my x values on a graph? Okay, sometimes. Yep. How about the domain? So we have domain and range. Domain is my x values and range is my y values. And then a rational expression is blank when the denominator is 0. Okay, let's think about our slopes. If my denominator is 0, we know that is a no-no, right? What do I say about those things? It can't be that, so what did I call that slope? Undefined. Okay? A rational expression is undefined when the denominator is 0. All right. So how do we simplify them? First thing that we've got to do is we have to factor the numerator and denominator completely. Then we will identify any excluded values. We can also call these domain restrictions. What variable goes with domain? My x values, right? So I'm basically asking what is x not allowed to be, okay? Our denominator overall cannot equal 0. After I have identified my excluded values, then we will divide out or cancel out any common factors that are in both the numerator and denominator. Okay? All right. Let's take a look at this. I'm going to zoom in just a little bit. All right, my directions here say factor each rational expression, identify any excluded values, then simplify. Okay, so I need to look at the numerator and denominator separately. If I have 3 terms, that has no GCF, we want to do the x method, right? Okay, but my leading coefficient is 1. That makes my job easier. I'm basically just asking right here, what two numbers would multiply to give me negative 18 that will add to give me negative 3? Negative 6 and positive 3. Okay? And then in the denominator, I had this x minus 6. Now, my excluded values, before I simplify, I need to identify my excluded values. That's basically me saying that x cannot be equal to a particular number. Okay? Now, what are we restricting here? The denominator, right? So my excluded values come from my denominator. If I take that x minus 6 and I set it equal to 0 and I solve for x, what do I get? 6. Do you agree that if I were to plug in a 6, 6 minus 6 is 0, right? So I am not allowed to have 6 as my x value. So that is my excluded value here. All right. Now I want to simplify it. Do you see anything on the top and bottom that look exactly the same? The x minus 6. So those cancel out. And all I am left with is x plus 3. That is my final simplified answer. Okay? So I was looking for two things here, my excluded values and the simplified expression. You can put parentheses around that if you want to. You don't have to. Okay? All right. Is there anything to factor on the top and the bottom here? What, just, is there anything that I need to like break apart right in parentheses? No. Okay. So the next thing that I want to do before I cancel anything out, I want to look at my denominator. If I take my denominator stuff and I set it equal to 0, okay, how would I solve this for x? What's currently happening? Multiplication, right? So if I divide both sides by negative 2, what do I get? 0. If I plugged in 0, that's going to be negative 2 times 0, which would make the denominator 0, which is a big no-no. So the number 0 is off limits. Okay? Now, the only thing that I can do here, ignoring the x, because there's no x on the top, the only thing I can do is divide out a 2. That leaves me with a 4 here and a negative 1 here. Would y'all be okay if I gave this negative to the 4? Just so it looks a little bit prettier. Negative 4 over x. I just like that better than the variable being negative. Okay, here we go. Next, I want to factor out as much as I can. I cannot do anything to the top. What is my GCF in the denominator? 3x. Now, if I took out that 3x, that left me with an x minus 3. If I were to distribute that 3x back in, am I good? Okay. Now, here I have two things that I would be setting equal to 0 to solve for x. Okay? anything that has a variable I am concerned about. So right here, my excluded values, I actually end up with two things. What are my two excluded values here?
0 and 3.
Perfect. 0 and 3. All right, and then, is there anything that the top and the bottom have in common? The x. Okay, now, this x will only cancel with that x. It will not also cancel with this one. This one can't be touched because it's in parentheses anyway, okay? Now, the numerator kind of just disappeared. What is technically still there? A 1, because there's an understood but unwritten coefficient. So I've got 1 over, that 3 is still there, and then I have x minus 3. And that is simplified as much as it can be. Okay. All right. Can I do anything to the numerator right now? Is there anything to factor? Nope. Okay. All right. Then the bottom is a trinomial. What two numbers multiply to give me negative 12, add to give me 4? 6 and 2. What are my signs? Positive 6 and negative 2. Perfect. Okay. So I'm looking at my denominator, okay, and I have two things with variables. Those two things give me my excluded values. What is x not allowed to equal here? Negative 6 and positive 2. Does everybody understand why without me writing it out to the side? Does anybody want me to write it out to the side? It doesn't matter to me. Okay. All right. Now, is there anything on the top and the bottom that looks alike? No. So I'm done. This is factored as much as it can be. So this is my final simplified answer. Okay? All right. Let's keep going. Hopefully we're refreshing our brains on factoring. Okay? I know getting our brains to math after fall break. It's going to take a little minute for the math to math. Okay? All right. What two numbers multiply to give me positive 4 but add to give me negative 5? Negative 1 is correct. How about negative 4 and negative 1? Are y'all okay? Negative 1 times negative 4 is positive 4, but negative 1 minus 4 more is negative 5. Okay? Ooh, what is this? It's a what? Okay, I've got perfect squares. What do I call that? A difference of squares. And that has a special factoring pattern. There's a plus in one, a minus in the other. And here I'm going to take the square root of what's in the front and the back. So I end up with x plus 4, x minus 4. What are my excluded values, y'all? 4 and negative 4. Rather than saying 4 comma negative 4, are y'all okay if I just put plus or minus 4? It's the same thing. All right. Then what do they have in common? The x minus 4, so I cancel those out. And my final simplified answer is x minus 1 over x plus 4. Can I cancel out those x's? Nope. As much as we wish we could cancel our x's sometimes, we can't. Ran into mine at the fair. Just kept walking. All right, here we go. Next, what is my numerator right here? It's a difference of squares. Yes, you're right, Aiden. X plus 1, x minus 1 for that factorization. It's a difference of perfect squares. Okay? Now, right here, I want to find the factors that multiply to give me negative 2, but add to give me 1. Positive 2 and negative 1. Okay? Now, before I cancel anything out, we got to do our excluded values, okay? What is x not allowed to equal here? Perfect. Hey.
Why do we do the excluded values?
Why do we do these? Like before I cancel, or just why do I do them in general? Both? Okay. Why do I do them in general? Because I have to put a restriction on what my denominator can and cannot be. If I plug in the negative 2, what's negative 2 plus 2? 0. And 0 times anything is 0, right? So either one of these values, no matter which one, if I were to plug them in for x, that's going to cause a problem, okay? Now, I do it before I cancel, or before I like simplify anything, because you've got to make sure that you account for anything that is a restriction. It doesn't matter if it cancels out or not. When we look at the graphs, if it cancels out, it's going to give me one type of restriction. If it remains, it gives me another type. But we'll look at that in a couple days. Okay? All right, now, what do they have that is alike? The x minus 1s. So I'm just going to cancel those out, and I am left with x plus 1 over x plus 2. Can I cancel the x's? Nope. Okay, we have a warning on this next one. Why do you think there's a warning there? Yeah, my order is different, right? I don't like my order to be different. So what I'm going to do, I am going to make it look how I need it to look. I need the x to be out front. But this isn't just any x. It's a negative x. And this is a positive 2. I did not change the value of my denominator. I just swapped the order because I need the x's to be out front. Now, right here, I don't like a negative leading coefficient. Okay? So there's nothing I can do up top. That's fine. Okay? But I don't want a negative x. So I'm going to divide out a negative 1 of both of those terms. If I take out a negative, what does it do? Changes the signs, okay? This was a negative x. Now it's a positive x. This was a positive 2. Now it's a negative 2. Now, do you see why that's helpful? Look at the top and the bottom. You see that? Okay? They will cancel, but before I cancel those, I only have one thing with a variable. Okay? This negative 1 I'm not even worried about because there's not even an x. if I were to identify my excluded values here, what is x not allowed to be equal to? Positive 2. Okay? Now, on the top and the bottom, I have both an x minus 2 and an x minus 2. What's understood to be left up top? A 1. And do y'all see how this is 1 divided by negative 1? What's 1 divided by negative 1? Negative 1. 1 divided by 1 is 1. 1 divided by negative 1 is negative 1. Okay? Okay. Now, down here on this one, I definitely have some GCFs going on. So in the numerator, I'm going to take out a 4x cubed. What does that leave me with inside? An x minus 1. Good. What can I divide out in the denominator? Only an x squared, yeah. That leaves me with x squared minus 1. What is that? Just that part right there. Yep, it's a difference of squares. So that means that my denominator is not factored completely. Okay? So I took out that x squared originally, but the x squared minus 1 factors into x plus 1 and x minus 1. Now, before I cancel anything out, I want to do my excluded values. Now here I have 1, 2, 3 different things to look at. Here I would set x squared equal to 0, x plus 1 equal to 0, and x minus 1 equal to 0. So what are my excluded values here? X cannot equal 0 or plus or minus 1. Excellent. Okay. All right, what do they have on the top and the bottom that's alike? Okay. Is that all? You got the x's. Yeah. So right here, I've got an x squared on the bottom and an x cubed on the top. That only gets rid of 2 of those 3 up there. Okay? So my final simplified answer is 4x over x plus 1. Can I cancel out those x's? No. As much as I wish I could. Okay? All right. Now we got to think back a little bit more, okay, before fall break. What is this? Difference of cubes. So I need to use the SOAP method. Okay? Same opposite, always positive. Okay? Now remember, I have a short set and a long set of parentheses. And then I get my signs set up. Same, put a minus in there. Opposite of subtraction is addition. And then the back will always be positive. Okay? Now, this is where we need to take the cube root of these things. What's the cube root of 125x cubed? 5x. And then what's the cube root of 8? 2. So I'm going to be working with 5x and 2. Let's go drop those in the first set of parentheses. Okay? What do I do in the first position? 5x times 5x. You square it. So that's going to give you 25x squared. You square the first one for the front, and for the back, you square the back one. So that's going to give me a 4. How do I get the middle? Perfect. Just the 2. You're good. Okay, so that's factored completely right there on the top. This does not factor anymore. Okay? All right. I don't like the order of the denominator. So I'm going to rearrange it. That's going to be negative 5x plus 2. And then I'm going to factor out a negative 1 because I don't like a negative leading coefficient. That's going to give me a positive 5x and a negative 2. Okay? Now, for my excluded value here, you would take your denominator of 5x minus 2 and set it equal to 0, right? Do I care about the negative 1? Why not? There's no x. Okay, there's no x. It's all by itself. Okay? So if I'm solving this 5x minus 2 for x, the first thing I would do is add 2 to both sides. And then I would divide by 5. So my only excluded value is I'm not allowed to have 2/5. What do I have alike? Perfect. Now, if all I'm left with is a negative 1 down in the bottom, are y'all okay if I just give that negative to the negative 25x squared plus 10x plus 4 and call it done right there? Okay. All right, for this one, I got 4 terms, so I'm going to factor by grouping. All right, now, for this first set of parentheses, I can remove an x squared. That leaves me with an x plus 1. And then right here, I can divide out a negative 4, which also leaves me with an x plus 1. So I have x plus 1 times x squared minus 4. Am I done with the numerator? If I'm asking that question, what do you think my answer is? No. Why? It's a difference of squares. So this is going to be x plus 1, x plus 2, x minus 2. Now that numerator is done. Okay, there is absolutely nothing else left to do there. Okay? Now, here in the denominator, I have a GCF of x that I can take out. Hey. The x squared and the negative 4 made this right there. Okay? All right. let's see, that gives me 3x squared plus x minus 10. Now I know there's going to be an x. I don't want to leave off that right there, but I am going to do the x method for this in the parentheses. 3 times negative 10 is negative 30, and I need that to add up to give me a positive 1. So I'm going to get that set up. And let's think about the factors of negative 30. What two numbers multiply to give me negative 30, add to give me 1? Positive 6, negative 5. Okay? Now, the 3 over 6 becomes 1 over 2. So that's x plus 2. And then I have 3x minus 5. How many x's do I have in the denominator right there? 3. So I need to look at each one to find my excluded values. The first two are easy. I got 0 and negative 2. What's this one going to give me? Careful. 5 over 3. That's all right. Positive 5/3. Because you would add 5, then divide by 3. Now, what do I have that's alike on the top and the bottom? The x plus 2. So I am left with x plus 1 times x minus 2 over x times 3x minus 5. Okay? Y'all have a wonderful day. We will pick up there tomorrow.